Today we're going to talk about rational numbers and irrational numbers. Let's do a quick review on how to put a repeating decimal into a rational number. Remember, a rational number is in the form of a over b, where a and b are integers and b is not 0. We have 0.8787 repeating. We want that as a fraction in simplest form. Well, if you remember, this is 2 repeating, so we're going to multiply it by 100. And then we're going to subtract the number. All the way out as far as we can go, we have to realize that those repeating decimals are going to cancel. Therefore, 99n would equal 87. Divide both sides by 99, and n equals 29 over 33. And that is 0.87 repeat, written as a rational number. You should remember how to do that. That was a quick review. Let's review rational numbers. Okay, we just talked about the form a over b, where a over b are integers. You should be able to take all of these and put them as rational numbers. 4, of course, is 4 over 1. Negative 2.2 would be negative 22 over 10, which would equal negative 11 over 5. Let's get to this one. This one's a little tricky. I'm going to take 100, I'm going to let this equal n, and take 100n, which is going to equal 35.55 repeating. And I'm going to subtract 10n. Now, why did I do that one a little differently? Well, because I just figured out that that's how I'm going to get all my decimals to cancel. And I get 90n equals 32, and n equals 32 over 90. Which equals 16 over 45. Okay. The density property, I'm just going to touch on this quickly. You should be able to do this. It's pretty basic. We want to find between any two numbers. Okay, this is the density property. It states that between any two rational numbers, there exists another rational number. Actually, just infinite rational numbers, if you think about that very long. So let's find what's halfway between 3/4 and 7/8. Well, here's 3/4 and here's 7/8, and halfway between them is going to be right there. Well, hopefully you can see that if you take 3/4 and add half the difference between the two, then you'll find the midway point. And that's what we did here. You can follow this on your slides. If we wanted to find the point a third of the way between those two, do you know what you would do? I want you to think about that for a minute. And yes, you would start with the 3/4 and add 1/3 of the difference instead of 1/2 of the difference. So study that slide and follow that through. If we need to order fractions or mixed numerals, we need to put them in common denominators. That's pretty basic. Or you can put them into decimal form. What I want to point out on this slide is that the square root of 2 is not a rational number. It goes on forever with no repeat. Pi, same thing. It goes on forever with no repeating pattern. These are two examples of irrational numbers. They don't repeat and they don't terminate. All decimals that either repeat or terminate are rational numbers. You can always put them in the form of a over b. And that's very important because we want to be able to often deal with exact numbers, not rounded or estimated. Let's talk about the square root function. If a squared equals b, then we take the square root of both sides. Okay, the square root of a squared equals the square root of b. A is going to equal the square root of b. Remember, the square root of a square is the base. The square root of b squared equals b. The square root of 3 squared equals 3. The square root of d squared equals d. And the square root of a to the 4th equals, who can tell me? A squared. Now we're going to get to two very important properties. The quotient property of square root states that the square root of a rational number is the square root of the numerator over the square root of the denominator. If we have the square root of 225 over 49, and we plug 225 over 49 into our calculator, we're going to have a mess to take the square root. But 225 is a perfect square, as is 49. So let's take the square root of the numerator and the square root of the denominator and get 15/7. And that's how we use the square root, the quotient property of square roots. Very important property. Well, there's also, you guessed it, a product property. The square root of a product is equal to the square product of the square roots. Let me say that one more time. The square root of a product is equal to the product of the square root of the factors. Let's put these two properties to work. Let's look at the first one. The square root of 324 over 729. Calculator's not going to help you on that. Let's factor 324 and see if we can find a perfect square. Yes, there's an 81 in 324 and there's an 81 in 729. So if we factor them into 4 times 81 in the numerator, 9 times 81 in the denominator, we can cancel out those 81s. 81 over 81 is 1. And we're left with the square root of 4/9. So now we use the product property to simplify that to this point. Now we're going to use the quotient property because the numerator and the denominator are both perfect squares. So we're going to change it to the square root of 4 over the square root of 9, which equals 2/3. The square root of 63 over 175. Well, they both have a factor of 7 that we can take out and eliminate because 7 over 7 is 1. We're left with a square root of 9 over 25. Well, 9 is a perfect square and 25 is also a perfect square. So we can apply the quotient property of square roots and come up with the square root of 9 over the square root of 25, which is the square root of 3. And you can read the last one. And I gave you the PowerPoints for that.